Good morning. Today we are going to start the subject engineering mechanics. Before this, I have not uploaded any videos related with engineering mechanics. Now I have first video which is basic concept we can have and what contents we are going to cover under this basic concept. So we have first a resolution of force, then we have equilibrium of forces. Then third, we have types of support. Then fourth, we have types of beam. Fifth, we have types of load. And sixth, we have free body diagram. So these 6 points we are going to cover in this video. Now, first we have resolution of force. Now let us consider a force and let it makes an angle theta having magnitude f. Now, generally, we have this value that is xy axis, and towards the right, we always consider as plus. So, we have this will be plus x axis, and we have this will be plus y axis. Now, this is f. So, now we are interested to resolve it. So, you can resolve along any axis, but now our interest is along x and y. So on this side we have minus, below we have minus. So now component of this, so now as it is making angle with x-axis, so we are going to get component along x-axis that is equal to fx equal to f cos theta. Now we have second component along y-axis. And that component we have, that is at y component. And then we have fx sine theta. So fy is equal to f sine theta. So two component. So we have this. And second we have this vertical. Vertical is y component. So we have front side, opposite side. So that is sine. And adjacent side we have cos. Adjacent is x-axis, so x component cos. Opposite is y-axis, so y we have sine. Now, if we will consider the same force, but angle is made with y-axis. So now what will happen in this case? As angle is y-axis, so we have this component is cos and this will be sine. So adjacent is always cos. And opposite we have sine. So now we have opposite will be this one. And then it will be x. So it becomes sine theta. So now you can have this. So we have x component. So fx equal to f sine theta because opposite side. So we have sine theta. And fy we have that is cos theta because it is adjacent. So adjacent we have cos. And then opposite we have sine. So likewise, we have to take components of the forces. Now, do not say always x component is cos and y is sine. You have to check angle is with x-axis or angle is with y-axis. If angle is x-axis, x component is cos. If angle is with y-axis, then we have y component is cos. Then we have second equilibrium of forces. Equilibrium of forces, that means your resultant force is 0. So when R is 0, we are going to say that is equilibrium of forces. So now let us, we will go, that is with axis xy. So now you can have this as plus, we have this as plus, we have this as minus, so we have this as minus. So when we are in this portion that is known as first coordinate, in first coordinate, my x-axis is positive, y-axis is positive. So I have both component that is x also and y also plus. Now if you will switch over to second coordinate, now you can see second coordinate, you have negative x-axis, positive y-axis, and therefore we have this value that is x we have minus in this coordinate and y we have plus in this coordinate. So when it is in this coordinate, x minus y plus. Now, if we will go to third coordinate, you can see this third coordinate we have x as minus, y as plus. So my both component are minus. So x is also minus, y is also minus. And we have this as last coordinate, which is fourth coordinate, which is bounded by x plus y minus. So x is plus, y is minus. So we have x plus y minus. So likewise, we have to take the component of the force. Now question, if some force is given, so we have given such force. And here we have given that axis. So this is my x-axis and this is my y-axis. Now, in which coordinate this force lies? If you have to decide the coordinate of the force, you have to always draw axis on tail of the force or opposite side of the arrow, and it will show it is in second coordinate. Though it is shown in fourth coordinate, but its line of action is in second coordinate, and therefore this force is considered in second coordinate. So if you have shown force here, then automatically tail side, we have this x and y axis we can use. But when arrow is given to the point O, then you have to draw line x and y axis on the tail of the force, and then you have to decide its coordinate. So now we have these values plus minus. Now we will consider some forces. So we have, let us, fx and fy. So whenever I will consider force, I will take its component. Now we have f1, and let us, this angle made by f1 is theta 1. So let us, we have this value as theta. Now f1 we have in first coordinate, so we have x plus y plus, angle is with x-axis, so we have x component cos, y component sine. So you can see f1 cos theta 1 and f1 sine theta 1. So this is first one. Then we have second force, that is f2 summation fx, because we are interested to find value of resultant. This is nothing but Rx. Resultant force in x direction. This is resultant force in y direction. Then we have f2. Let this f2 makes an angle with x-axis, that is theta 2. Now you can see angle is with x-axis. So again x component we have cos, y we have sine. Now we have in second coordinate x minus y plus. So you can see minus f2 cos theta plus f2 sine theta. In second coordinate y is plus. Now we will go to the third coordinate, which is f3, and it is making an angle theta 3 with your x-axis. So we have this as theta 3 in third coordinate. So x is also minus, y is also minus, and the angle is with x-axis. So x component cos, y component sine. So we have minus f3 cos theta 3, minus f3 sine theta 3. I have shown colors of the component same as the color of the forces. So you can easily identify the component of the respective forces. And then we will go to the fourth. So we have, this will be f4. So we have f4, that is equal to, so I come to know this is green. So let us, I will show angle by green actually. All we have to show in that color only. So let us now, we have only this theta 4, and then as it is theta 4, fourth coordinate, x component we have plus, y component minus, angle is with x-axis, x component cos, y component sine. So we have plus f4 cos theta minus f4 sine theta. And now from this, we are going to get these values of the resultant force. Now, if we have resultant force 0, then my body is in equilibrium, or otherwise, if body is in equilibrium, then my resultant forces are 0. So as we are going to say equilibrium, so I will say this is totally equal to 0 where I have Rx equal to Fx equal to 0, and then we have Ry equal to Fy equal to 0. So all these components algebraic sum are 0 in both x and y direction. Then we will switch over to the third types of supports. So we have three supports. First is roller support, may be shown like this. Then we have simple support, roller support may be shown like this, or it may be shown like this, mentioning this surface is frictionless. And so it is frictionless, so it will act as a roller support. So now, second we have pinned support shown by this. It may be shown by this. So we are in this fashion. And then third, or it may be shown like this. So if we will consider this, and if you have shown dot in this, so this dot, this will show your support is simple support. So this dot is important. That shows you have pin support or simple support. And third is fixed. So now you may see this and this same, but here you do not have any dot. So this is fixed supports. Now how we will have reaction in this? So you can have this roller support perpendicular to the plane of the roller. So you have it can roll in this direction and cannot roll in this direction. So reaction is always in the direction of restricted displacement. So now you have reaction over here, and allowed displacement is delta H, and then theta, that is your rotation. Means if you will consider any beam and if you will show it, then it will bend like this. That means you have rotation over here. So a roller support can allow horizontal displacement or displacement in the plane of the roller and then rotation. Then in this case also, we have these two, and then my reaction is like this. But in this case, my reaction is always perpendicular to the support. So we have like this. Means if anyone show roller support in this fashion, then my reaction is perpendicular to this. So I have this as R. Now in case of pin support, I have two reactions and only one displacement theta. So this is R1. Horizontal I will mention R1. This is R2 and theta is unknown, which is 1. Here theta is 1. Sorry, delta H is 1. This is 2. And one reaction over there. So same way we have reaction over here. And in this case, you have two reactions perpendicular to each other. And then in case of fixed support, we have three reactions. So my displacements are 0. You have reaction or you have displacement. We have three portions where we have to consider. One, we have horizontal. Second, we have vertical. And third, we have rotation. So if you have vertical reaction, then my vertical displacement will be 0. As I have vertical reaction, horizontal reaction, my horizontal displacement is 0. My vertical displacement is 0. Means you have a reaction or you have displacement. And so totally if you will see, in all cases, you will get it as 3. So you can have one reaction, then you can have two displacement, 1 plus 2 you have 3. Here you have two reactions and then displacement is 1 only. So total is 3. So here no displacement. So we have 3 reactions, total is 3. Only we have two exceptional cases in which displacement and reaction are simultaneous. One is spring and the second is sinking. In these two cases, we have a reaction and a displacement. Both are simultaneous. So we have to keep in mind. So if displacement is restricted, then only reaction will be developed. Then we have types of beams. So we have simply supported beam. One will be simple support, another will be roller. Both will not be simple support. If you are going to consider both support as simple support, then you have this is indeterminate beam. And then we have to use problems to solve, that is compatibility equation. So here we have in simply supported one simple, another roller support. Then we have cantilever, one end fixed and this end is free end. No support is there, so known as free end. And this support we have fixed support. So you can show like this also. Then we have third compound beam. So this roller, this is used to transfer load from one beam to another beam. To transfer load only. It cannot resist any reaction. It will not reaction. It will take load from upper beam and that load will be transferred to the lower beam. Only that is its work. So that is it only transfer load from one to another, take from one and give to another. It cannot have any reaction over this support. Then it can be in this way. So if you have load more on one beam, then by using internal hinge, we can transfer this to another beam. So these are the media actually to transfer load of one member to the other member. So you can have like this also. So you can see here we have simple, you can have, if you will consider this beam separately, then you can have simple support, roller support. And if you will consider another beam, then whatever reaction you have over here, that reaction will be here. No support will be over, and both will be again act as simply supported beam. And therefore, likewise, it will be transfer of the load from one member to another member by internal hinge or by taking a roller in between the two beams. And these are known as compound beams. And moment about internal hinge is always 0. So you can see equilibrium equations we have 3 and one equation will be developed by internal hinge. So we will get equilibrium equations 3 and internal hinge 1. So total equilibrium equations becomes 4 and we can find 4 unknowns. Here also we have 3, 1, 2 and 3 and this is 4. So again we have same concept over here. And then we have types of loads. So we have concentrated load acts at a point. Load never act at a point, but the base is very small and therefore we are going to consider it as a point. Then we have uniformly distributed load. So we have this UDL, uniform throughout, means the value of this load is uniform at each and every point. So known as uniformly load. And then total load of this will act at the center of this. Now we have vertical height W kilonewton per meter L span, and then total load will be area of this load diagram. So it is rectangle. So we have base L and width W. So W into L will be total load and will act at center L by 2, L by 2 from both sides. We have uniformly varying load, means it varies uniformly. So you can see we have like this. And then we have W will be the height, 0 will be here, L will be the span. Then we have total load, area of this diagram, and area of this is 1/2 base into height. So 1/2 base is L, height is W because area of triangle. And it will act at centroid, that is from right angle 1/3 and from 0 height 2/3. So we have L by 3 and 2 L by 3. So these loads act at centroid of their area. And then we have last free body diagram. What is free body diagram? It is simply show the relative magnitude and direction of all forces acting upon the object. Means if we have support, we have to remove it, supports, and we have to show appropriate reactions. And that we are going to say as free body diagram. Simply supported beam, You have to remove simple support, show two reactions, remove roller support, single reaction. If you have cantilever beams, remove support, show three reactions. If you have compound beam, now you can see this. So we have for this simple support, we have two reactions. Then for this roller support, we have reaction R. Now if I will go to the bottom support, then I have this reaction R dash. These are always in equal and opposite. It will take a load from this beam and transfer it to the another beam. So it will not act as reaction. It will be a media to transfer the load. Then we have for this simple support two reaction. For this roller support one reaction. So now if we will go to this, then we can have simple support two reactions, roller support one reaction, roller support one reaction. So likewise, we have to go for the free body diagrams. So this is all about your basic concept. So now we will stop here only. You can see now I am going to prepare a playlist, and in that I will add all engineering mechanics video, and for that you have to subscribe Civil Engineers Technical Hub. So now I will stop over here. Thank you.